In this video, we are going to look into sketching the graph of a quadratic function f(x) is equal to ax square plus bx plus c. We know that the general shape of graph of a quadratic function is a parabola, and depending on the value of a, we can then sketch the general shape of the parabola. If a is greater than 0, then the parabola has a minimum point, and if a is less than 0, then the parabola has a maximum point. To sketch the graph of a given quadratic function, the following information are required. First one, we should know about the general shape of the graph. General shape of the graph. And as I just told you that this basically depends on the value of a. So if a is positive, then this is the general shape of the graph, and if a is negative, then this will be the general shape of the graph. The second piece of information which is required in order to sketch the graph is the axis intercepts. It means that whenever we are sketching a graph of any given quadratic function, for example, this is our sketch, then we need these points, the points where the graph of the quadratic function f(x) is equal to ax square plus bx plus c intersect or intercept x-axis as well as the point where this graph intercept y-axis. So we need the values of x-intercepts and y-intercepts. You can see that it is quite easy to get the values of x-intercept here. When we want to work out the values of x-intercept, the y value or the y coordinate is 0, and when we want to work out the value of y-intercept, then the x coordinate is 0. We know that the coordinate at the origin are 0, 0. After getting these points, another piece of information is useful in order to work out, in order to sketch the graph of a quadratic function, and that third piece of information is the coordinates of the vertex. So this is the vertex and it has coordinates x and y. Once we have all these pieces of information, we are then able to sketch the graph of any given quadratic function. The best approach to sketch the graph of a quadratic function is to change the original function, original quadratic function, into its completed square form. So if my original function is ax square plus bx plus c, and after converting this one into completed square form, I will get p into x minus q whole square plus r, where p, q and r are constants. Then it is quite easy for us to get the values of x-intercepts, y-intercepts, the coordinates of vertex, and hence we are then able to sketch the required graph. Let us try to understand it by taking a simple example. Sketch the graph of y is equal to 16x minus 7 minus 4x square. So we are asked to sketch the graph of this function. You can replace y with f(x), it doesn't matter. f(x) is equal to 16x minus 7 minus 4x square. Both are the same. So in order to sketch this graph, as I just told you, first of all we will convert this function into its completed square form. So our function is, if I rearrange the function in descending order, minus 4x square plus 16x minus 7. So out of the first two terms, we can easily take negative 4 as a common factor, and we will get x square and minus 4x. Then we have minus 7. Now, if you know how to convert a given quadratic function into its completed square form, you can just simply change it, just a quick review that focus on this number, which is the coefficient of x. This is minus 4 and divided by 2, you will get minus 2. Now, our completed square form will be x minus 2 whole square, and then subtract the square of negative 2 from the bracket and minus 7. And then finally, multiply out this bracket, minus 4 into x minus 2 whole square minus square of minus 2 is plus 4 into minus 4 is plus 16, and this negative sign will change it to positive. So, we will get plus 16 and then minus 7, which was outside the bracket. And then further simplify it, minus 4 x minus 2 whole square plus 16 minus 7 is plus 9. So, here we are. Our function is now changed into the completed square form. Once you have changed this function into completed square form, we can then decide about few things. Number one, general shape of the graph. Number two, coordinates of vertex. And number three, the x and y axis intercept. So, the axis intercepts. So, general shape of the graph can be obtained from the original equation actually, and we can see that the original equation was minus 4x square. So, the value of a is negative 4. So, a is basically smaller than 0. So, a is negative. When a is negative, the general shape of the graph has a maximum point, sorry. So, that will be the general shape of the graph. Okay. Then, to work out the coordinates of the vertex, we will focus on this part, the completed square form. In this part, if we take this one, x minus 2 and equate it to 0, we will get the value of x. So, x coordinate of the vertex is 2, and inserting this value into the function y is equal to minus 4 x minus 2 whole square plus 9, we will get minus 4 2 minus 2 whole square plus 9, which will give you 0 plus 9. So, y is equal to 9. Therefore, the coordinate of the vertex are x is 2 and y is 9. So, you can see that how simply we can work out the coordinates of vertex by the completed square form of this quadratic function. In simple word, this is the y coordinate, and from here you can get the x coordinate. Now, after getting the general shape of the graph and the coordinates of the vertex, the last quantity which is required in order to sketch the graph of a quadratic function is the x and y intercepts. In order to get x and y intercepts, let us again look into the equation, the completed square form of the quadratic function, which was minus 4 x minus 2 whole square plus 9 is equal to y. We will insert first y is equal to 0 in this equation. So, we will get minus 4 x minus 2 whole square plus 9 is equal to 0, and solving this one, you will get x minus 2 whole square is equal to minus 9 over minus 4, which is, if you cancel negative and negative, you will get 9 over 4, and then taking square root of this function, you will get x minus 2 is equal to plus minus 3 over 2. Now, either x minus 2 is equal to positive 3 over 2 or x minus 2 is equal to negative 3 over 2. This will give us two values of x, which is x is equal to 3 over 2 plus 2, which will give us 3 and a half, and this is negative 3 over 2 plus 2, which will give us 1 half, 0.5. So you can write this one as 3.5 and this one as 0.5. So these are the values of x-intercept. So our graph of the quadratic function will intercept the x-axis at 3.5 and 0.5. Finally, we need to know the value of y-intercept as well. So again, let us look into our equation. Minus 4 x minus 2 whole square plus 9 is equal to y. Now in this equation, if we insert x is equal to 0, because we know that for the point for y-intercept, x coordinate is always 0. So minus 4, 0 minus 2 whole square plus 9 is equal to y. Solving this one, you will get y is equal to minus 7. So all the parameters which are required in order to sketch our graph are available now, and using all these values we can then sketch our graph. X is 3.5 and x is 0.5, y-intercept is minus 7, coordinates of vertex we already worked them out is 2 and 9, and the shape of the orientation of the graph is like that. That is, the graph has a maximum point at its vertex. So having all these information, we can easily now sketch our graph. Let's say this is 0.5, here we have 3.5, then somewhere along the line here we have minus 7, and that will be our let's try to be a little bit more accurate. So this is the sketch of our curve. This is vertex, and the coordinates of vertex are 2 and 9. So this point here is 2 and this one is 9. So I believe that you understood the concept of sketching the graph of a quadratic function. We have seen that to sketch the graph of a quadratic function, we have to convert the quadratic function into its completed square form. Then from there we can get the coordinates of vertex, we get the x and y intercepts, and from the sign of coefficient of x square, that is the sign of a, we can decide about the orientation of this graph. That's all for now. See you next. Take care.